Okay, welcome to our first class. So here we're going to take a look at proof and reasoning and proof. So what is proof? Videos are going to be more like showing you what flipped classroom is going to be like. So this is something you might get to see more of as we move forward this year and then into next year with university and whatnot. It could be something that is going to become a norm. So we're going to do both of this. But first, there's going to be a little level of learning for your part because it's going to be, this is the idea of flipped classroom where I assign this as the homework. You have no other homework but to go through this in examples. Sometimes I'll just give you the examples and go over the theory in class. But really the whole idea of that is so that we're spending in-class time working on problems and really honing in on what areas of math are you having trouble with, particularly with the topic at hand. So it's really engaged and focused learning on that those gaps that you might have to understand these concepts. So that's what allows us to do this. And those that don't have much or struggle less can easily continue and get through the material, if not faster, right? As I produce some of these, you might even be able to jump ahead if you so choose, right? It all depends. But here's the idea. So what is proof? So this mathematical proof is a correct argument which establishes truth of a mathematical statement, right? So it has a hypothesis and conclusion. So math is all about forming arguments. So that's what this is bringing in more of the logical structures. So these are logical connectives that we're going to be using and showing, not necessarily proofs because that's really meant for higher level, but for us, we want in the SL to do a rudimentary version. So it's a derivation or be able to at least form and write mathematical statements, being able to use some of these sort of logical connectors. So what do some of these mean? And is this little caret. This is a little, I don't know, cup or vase, V. Not negation. You're going to see what negation means. If-then statements. If A happens, then B is a consequence of A, then that's an implication. If and only if is the statement, it can work in both directions. So this is working in one direction. Equivalent means it's true in going to the left to right, and it's true if you reversed it, saying B implies if B then A. That would then be if and only if kind of statement, right? So give a little bit of an explanation to these connectives here. So this is A and B, right? That would be A and B implies C, right? So this is using those sort of logical connectors. Negation is simply saying the opposite of the original variable. So if A is cat, well then not cat. Or you can say then dog, right? It's like it's vice versa, but it's just going to say that it's false. So if A is true, then not A is false, right? So that's basically what it says. Implication, is the implication of A implies B. We start with the statement A, and from it we deduce that statement B, right? So statement A is called a hypothesis, and B is our conclusion. The converse is if we switch the two around, B then A, right? So this is just an example. So if you have x equal to 2, then x squared equal to 2. This is true. However, the converse, x squared equal 4, then x equal 2. That's not necessarily true because if you think about what here, this is going to be, because it's x squared, well, that could actually be plus or minus 4, right? So I need a little thinner. So it could be that x is minus 2, so it's not necessarily true. So that's just an example, right? So we're going to look at statements like this. So if we are looking for negation, so equivalence, I've already stated, this is just saying that it's going to be true in both directions. So here's a nice example that I would guide you to. Have a look at that. For each statement, the negation. So a negation of that, well, the cat, you could even say the cat is not black. But you could also say, or we could say the cat is white. Right? That's just saying, right? So then that's a negation of that. There's your not, right? So again, this is our statement A, and then this would be an A, not A, right? So they're just using this little notation, this kind of crooked L. So then we have X is prime. Well, then you could say X is not prime. Right? I'm actually going to just zoom in on this a bit more so we can... Or then you can say, well, actually, let's just keep it X is not prime, right? So we could then say here for C, the tree is not deciduous. Right, so the tree is not deciduous, right? So there's examples. So a proof by deduction, right? So a proof by deduction is something that you would do if we have used algebra to show a different result, right? So in the course of using algebra, we show that it can be done differently, right? It's a false statement. Or something else is true, then showing that the original statement is false. And this is what we're going to see in this example. So given some information of the hypothesis, and then there's asked to prove something, the chain of implication, right? This is the proof of deduction, right? So then let's just take a look. It's always going from left to right. Okay, so let's just take a look at this. A. So if we have this, we already see if X is less than 5, then this is true. Well, if you think about it, like, okay, minus 6, we test it out, and that's squared. Hey, yeah, that does seem, we know that this is 36, so just by thinking about that, that's true. Okay, but let's just take a look at it. Let's take a look, proof by deduction. So let's see here. So if we say this were to be true, we could then say the following. If X less than minus 5, because the trick here is this statement right here, right? So if we're going to say if X is less than 5, right? Then it's got to be greater. Oh, okay. But then what happens? So we have if X is less than absolute value. So we're going to use an absolute value here, greater than 25. Oops, no, we don't want that. We want 5, which we already kind of know. Now we want to get rid of this square, and we know that already. We have to recall that that is defined to be this strange thing, right? You can actually do this. So if you square both of those, so you could rewrite this, the absolute value, as this. And you know if you square this, square that, this would then be equal to X, right? It would be, well, X in that case, or X squared. Sorry, I'm going to keep it like this. And then this would then be, because remember, we're just going to go like that, and then that's equal to X squared. It undoes the radical. So then what we can say then, if we square both sides, we then would have X squared 25. That makes sense. However, if we're then going to say, therefore, you would have this. If you think about this, though, which is a little concerning, right? So explain why the converse is, so that's true. So we've actually shown that to be true. But here's going to be something we can kind of see that I've already seen that that's kind of true. So we've also shown using absolute values show that that statement is true by deduction, and you have to use that absolute value. Remember what the converse is. Converse is, here's my A, here's my B. Switch them. So then that's going to be B implies A. So we're going to say B implies A, which means if x squared greater than 25, then x is less than minus 5. But clearly, if you know about what the square is here, it's clearly not true, because you can have certainly minus x, or sorry, you can have this. You would have x6 squared is greater than 25, which is true. So, yep. However, 6 is greater than minus 5. And that's not what we want, because we're looking for x less than minus 5, right? Because in this case, right here, we have x could be equal to minus 6, or it could be x equal to 6, right? So we have to take those into consideration when doing that type of problem. Okay, so that does it for this first lesson, right? So hopefully I'll get a little bit faster next time and go through them, but you can now get the idea of what to expect with these kind of flipped classrooms. And then we work on the problems in class, right? So next time I'll try and get right to the meat of it first, or maybe I'll just give you the examples and we come in and you've seen the examples and you kind of have skimmed over the theory, and then it's like, okay, you have questions on the example themselves and we can go over that. Okay, so see you Monday.